Yep.
Okay, 3, 2, 1, and I think that's us going.
Okay, well, welcome everybody to the third session on Llama 2. With me being inundated with tasks, I asked Yasser if he could take the last third, and he's very kindly offered to, so swept in there to help us all out with understanding this last part. Yasser, yeah, well, has hopefully stable internet, but if there's ever any instability, then we'll have to make do. But fingers crossed the internet survives. But yeah, anyway, without further ado, thanks again, Yasser, for covering the last bit, and I'll hand over to you.
Yep, thanks a lot, Daniel. So we've had 2 parts on Llama V2 at this point. This is hopefully the one where we conclude the paper. So Dan has covered almost everything before the safety section. I guess a quick recap on what Llama V2 is. It's the latest iteration on the Meta-Llama models. The only difference between Llama 2 and Llama V1 from an architectural point of view, it's only probably the extended context length. It's 4K now, and the grouped query attention, which projects the query into n heads, but keeps the keys and values only a single key and value across heads, which makes the computation more efficient. That's probably the only difference in terms of architecture, but the novelties come from the different data mix they used, the prolonged training, so it's trained on 2 trillion tokens instead of 1.4, I believe. And yeah, and the way they train it, the supervised fine tuning and the RLHF, that's done with the safety and helpfulness reward models. So all of this was discussed in the previous parts. So in this part, we are concerned with the last 2 sections, the safety section, which, as the name suggests, it talks about the safety measures that have been taken to make sure that Llama 2 models, the chat versions at least, do not output or respond to any prompt that might invoke toxic behavior or help with any kind of criminal behavior, etc. This is all detailed in this section, how they've done it. And the last section is the discussion. So the discussion section talks about very interesting findings that the authors, very interesting findings on the site that the authors have found during training, which I'm actually quite excited to share with you guys. Without further ado, let's get started. So safety in pre-training. So maybe a brief primer on how these large language models are trained. So usually you start off by pre-training. You start up with the pre-training phase, which is basically training these large language models on tons and tons of text, tons and tons of data. And again, in the case of Llama V2, it's 2 trillion tokens. And the point of this phase is to basically, put all kind of knowledge into this model. It's the phase where the model learns about everything, the structure of the task at hand, the structure of the language, and all of this jazz. And all of this is done through next token prediction. So there's nothing really special, but apparently these models, when they are trained for long enough and when they are big enough, emergent behavior starts to show up, and they perform very well on different tasks in a 0-shot or a few-shot setting without being explicitly trained to do so. We call these models foundation models. So once we have this foundation model that has so much knowledge, the next step is to, if you like, you could start fine-tuning it in your downstream task, or if you're like building a chat model that's supposed to have a back and forth with the user, you start doing what's called alignment phase. This alignment phase, the point of this alignment phase is to make sure that the model output is in alignment or in alignment with human preferences, whatever human preferences might mean, because this is obviously subjective. But normally this alignment is done through supervised fine tuning. So you start showing the model prompts and responses that are annotated by trained annotators, and then you might perform reinforcement learning with human feedback that further aligns the model to your preference. It's important to note that the alignment phase doesn't really introduce any new knowledge to the model. All of the knowledge is taken from the pre-train phase. Like the model learned a very complex and big distribution. And the point of the alignment phase through SFT or RLHF is to constrain this distribution. So the model tries to output specific generations in a specific parts of the distribution, because when a model is trained on like the internet, there are all kinds of stuff, toxic behavior, like every kind of internet personality is fine there, and you don't want the model to output everything. You want it to be accountable, responsible, wise, all of that. So the point of the alignment phase is to make sure that the model just uses this specific part of the distribution and ignores the toxic part, or gives less weight to the toxic part. But the point is, it's not really learning anything new. In fact, we are in some sense performing regularization or constraining it. So that's an important point to put in mind. So why am I starting with this monologue? Well, Llama 2 basically goes through three phases. The first being pre-training, obviously, then SFT, which is supervised fine-tuning, and then RLHF. So every layer, every phase has its own security or safety measures that have been taken. The first phase being pre-training. So what have they done there? So steps taken to pre-train responsibly. So the authors didn't use any data, any meta-user data in training. I guess they're referring maybe to Facebook and sites with personal data. So we excluded data from certain sites known to contain a high volume of personal information. So that's the first thing they've done. They made sure that data doesn't contain any personal information, and they made best effort to train their models efficiently to discover for pre-training. So there's also this trend and care about the environment that researchers have been moving towards lately. And also sharing the models means not much people are required to train the models from scratch. So again, this is a win for the environment, I guess. Saying that, there wasn't any additional filtering conducted on the dataset. So even though there might be some toxic data found or like hateful data, etc., found there, they didn't filter that, and the rationale being while avoiding the potential for the accidental demographic erasure, sometimes caused by overscrubbing. So they're worried that if they do that, they might remove some minorities due to the overfiltering or overscrubbing of the data. And also, I guess this is a very interesting point and important as well, which is it allows the fine-tuned Llama models to generalize more effectively during the safety tuning. And so what does that mean? So if the model hasn't seen, if you filter out the toxic data from the pre-tuning data and you try to downstream, like fine-tune it on a downstream task, let's say toxic language identification, it would be difficult to recognize what's toxic when it has never seen toxic language. So the reasoning behind leaving some of these toxic or hateful or whatever you want to call it data in the pre-training dataset is to make sure that the model in further fine-tuning could easily detect these toxic bits, which they mention as during safety tuning. With it takes fewer examples to make the model safer, basically. Yep. As a result, Llama 2 models refers to the pre-trained Llama models before SFT and RLHF should be used carefully and deployed only after significant safety tuning is applied. So here they do some kind of statistical analysis on the pre-training datasets. They try to understand what's contained there. So they present some of the demographics. So in terms of the pronouns, as expected, you'll find the he pronoun being present way more than the she pronouns, and male compared to female. Same goes with the identities we're speaking about. For example, gender and sex, you might find males more than females. For religion, for nationalities, you might find more of the Western, American, European makes most of the nationalities there. And in terms of religion, it's Christian, Catholic, and then Jewish. So what's the point of all of this? It's being transparent and just knowing the biases and the stereotypes and all of the biases that might be found in the data. So when these biases are observed in the fine-tuning phases, or like when using the model, you can where it's stemming from, what's the reason behind this. And again, it helps you have a direction when fine-tuning the model, that there's these specific problems that you need to account for when you fine-tune these Llama models. So like in short, when it comes to the pre-training data set, all of they've done is just made statistical analysis and just learning what's in there. They didn't like filter anything or like rebalance stuff. They didn't do any of this. You're just presenting the demographics. They did also check for the amount of toxicity in the data set. So we measured the prevalence of toxicity in the English language portion of the pre-training corpus using K-BERT. So K-BERT is basically a classifier that's fine-tuned on the Toxigen dataset. That's a famous dataset of toxic language. And when they did the scoring, they found there's only about 0.2% of the documents that were considered toxic, or at least like they were above 0.5 or higher. So again, they didn't remove these toxic bets for the same reasoning I mentioned a few minutes ago. And again, in terms of language, obviously English was the dominant language, with some other languages existing, but in a very low percentages. Yep. So in terms of like the pre-training data set, all of what they did is just basically understanding what kind of data they're working with. Again, there was not any kind of filtering beyond the personal information thing. Other than that, they were just understanding, okay, we have these kind of biases, so like tread with caution. Anyway,
did they mention much on the unknown? I find it interesting that that's the second biggest one. Like, what does that
mean? Code, it's just called programming code data. Partially programming code data.
Okay, fine. Yeah, okay. Got it. I was going to say that's weird. It's like so much internet, it's like some language that people don't know what it is. Okay.
Exactly, yeah. They were using fast text for this. Yep.
Okay, and this is just because, like, I've forgotten the name of it now, but the main thing where it's all web scraped and you basically just take, like, I don't know, all of the internet and without personal data and create a data set from it, that just the vast majority of the internet, for various reasons, is English. Is that basically the point here? Is that why it's like 90% English?
I mean, I'm not sure, but I think this statement is still probably true anyway. Like, even if they did that, then probably most of the data will be English.
I guess, yeah. I guess it's just it's 90%. I mean, maybe it's just interesting just to see. I guess also because when you talk online, obviously, when you talk across boundaries, with English being the international language, I certainly wouldn't think that. I certainly would think that a small minority of that is actually like native speakers, because I guess it's more just because when you talk online, people like obviously generally use the more internationally accepted language. But I don't know. I'm not sure exactly, but interesting. Anyway. But anyway,
I think it doesn't come as surprising that English is the most dominant language.
No, certainly not the most dominant, but kind of going from 90% to like 0.17 is like DE. I mean, is that German or Dutch or I don't know exactly, but or French, like kind of going from 90% to like a fraction of a percentage, and French or something is surprising to me a little bit, but
Anyway, moving on. So here they're talking about the safety benchmarks for these pre-trained models. So they evaluate the safety capabilities of Llama 2 and 3 popular automatic benchmarks, pertaining to 3 key dimensions of LM safety. First is truthfulness, which refers to whether a language model produces known falsehoods due to misconceptions or false beliefs. So they use the truthful Q&A data set to measure how well their LLMs, not ours, can generate reliable outputs that agree with factuality and common sense. I guess this refers to, like, I don't know if was the moon landing fake or not, or stuff like that. So just making sure that the model doesn't output any kind of misconceptions or fake information or conspiracy theory narratives. And then you have the toxicity, defined as the tendency of a language model to generate toxic, rude, adversarial, or implicitly hateful content. We choose Toxigen this was the same data set used to fine-tune the hate bird that was used to identify the toxic bits of the data set and the pre-training data set, to measure the amount of generation of toxic language and hate speech across different groups. And lastly, they were checking for bias, defined as how model generation reproduce existing stereotypical and social biases. And they use the bold data set to study how the sentiment and model generation may vary with demographic attributes. So before I can move on, I guess it's expected that the performance on these dimensions, especially the toxicity one, won't be that great, at least. It's an improvement when compared to Llama 1, but again, these models have been fine-tuned yet on the safety measures. So we're not yet expecting like marginal differences. But anyway, when compared to Llama V1, the Llama 2 demonstrates like 20% increase in truthfulness and informativeness, and like 7% decrease in toxicity. We also observe an increase in toxicity in the pre-trained 13 and 70 billion Llama 2, which may result from larger pre-training data or a different dataset mix. So the first thing we see this improvement. I guess this improvement only has to do with the different pre-training data sets. Like because Llama 1 was trained on a different data set, this is Llama 2 is trained on a different mix. Because as far as I can see, I don't see anything used here that's supposed to make the models like less.
They mentioned.
Less biased.
No, they did mention in the beginning, in the first section of the paper, that they amplify truthful sources, and so they kind of duplicate, let's say, Wikipedia articles and stuff. Yeah,
exactly. That's what I'm saying. I mean,
why.
the only difference comes from the pre-training data, because it's different. So they have probably like accounted for that in their pre-training data. Yeah.
Well, no,
But, I mean,
they explicitly said that they like amplify the truthful content more than they did in Llama 1 and stuff. So I guess that's probably why it's more truthful, for example.
Exactly. Yeah, exactly. I mean, yeah, exactly. It makes sense because the pre-training data is different, and as you said, it's like they consciously amplified the factual.
And I guess that also kind of comes hand in hand, because Wikipedia articles aren't typically toxic, or like encyclopedias aren't.
Yeah.
So I guess they kind of do both.
Yeah.
A bit,
usually, yeah. Yeah, makes sense. So I mean, so far they haven't done like any training tricks yet, and we've seen improvement just by the fact that they've just made the data a bit better than Llama 1. Yeah, but again, there's this interesting observation that they mentioned, which is the toxicity of the larger models seem to increase, and so there's this. So some have like they're thinking that it might be because the data size is bigger or the model is bigger, but there's research still on this on why this happens, why the bigger models are more toxic. Anyway, moving on. Let's see this. We present bias metrics such as how sentiment of model generation varies with demographic attributes. We note an increase in positive sentiment of model. Yeah. Again, this has to do with the new data set probably. Llama 2 does not outperform other models on toxicity metrics, which is expected, and we speculate this may be because we refrained from aggressively filtering the pre-training data. So I guess this is common sense. We call that leaving, so this is the reasoning that I mentioned a while ago. We call that leaving pre-training data unfiltered may enable base models tuned to perform well on more downstream tasks, including hate speech detection. I guess this is obvious. Why? Because again, if they already have an idea what hate speech looks like, they can easily classify or identify it. And it carries this risk of accidentally filtering out some demographic groups. Okay, we observed that models trained from less aggressively filtered training data also require periodic examples to achieve reasonable safety alignments for the exact same reason as why it would perform better at identifying hate speech detection. I guess this part is clear, right? Yep. And then they reiterate the fact that Llama 2 models, the pre-trained version should be, they should go through some fine-tuning phase where they're like additional safety mitigation should be applied before deploying them. Yep, these are the results on the pre-trained models. So Precision, lower is better. So as you can see, the Llama 2 ones, they're almost the same. I mean, in some sense, they're close, I guess. Here. Yeah. So again, all of this is on the pre-trained models. The tricks and the magic happens when they do what they do in the SFT phase and the RLHF phase. So let's move to the safety fine-tuning. So now we have this pre-trained model that's not super safe, and we want to make it safer. So how did they do that? So safety fine-tuning. In this section, they describe their approach to safety fine-tuning. Okay. So the very first thing is supervised safety fine-tuning. So we initialize by gathering adversarial prompts. So adversarial prompts, what does that mean? It means tricky prompts. In short, it means prompts that might provoke the model to output something toxic, something unwanted. The word adversarial prompts could have a more technical meaning, which like it might mean that a prompt that's very well engineered and well made that hacks or jailbreaks the model in some way. I believe here it really means the more general meaning, which is tricky prompts, not like prompts specifically engineered for this model, where it can like trick the gradients and all of this, which is famous in image models. Anyway, so they gather adversarial prompts and safe demonstrations that are then included in the general supervised fine-tuning process. This teaches the model to align with our safety guidelines even before RLHF, and thus lays the foundation for high-quality human preference data annotation. So basically, start collecting very tricky prompts, very adversarial prompts, and they start writing responses to these prompts that follow their safety guidelines, and they start supervise. They basically fine-tune the model on these prompt and response pairs, so the model can basically, when met with adversarial prompts, it responds with a safe response. And then when they use safety RLHF, subsequently we integrate safety in general RLHF pipeline described in section. Yep. This includes training a safety-specific reward model and gathering more challenging adversarial prompts for rejection sampling style, fine-tuning and PPO optimization. So this again was like explained by detail in the previous parts. So in the training of Llama 2, there are two reward models that are used in the RLHF phase. There's the helpfulness reward model. There's also the safety reward model. And the model is optimized in RLHF to output texts or responses that are both helpful and safe. So they have two separate reward models for these two tasks, and they're going to go into details on the tension between these two tasks. And finally, safety context distillation. Finally, we refine our RLHF pipeline with context distillation. This involves generating safer model responses by prefixing a prompt with a safety pre-prompt, like your safe and responsible assistant, and then fine-tuning the model on the safer responses without the pre-prompt, which essentially this is the safety prompt, pre-prompt into the model, use a target approach that allows, So all of this is going to be discussed in fair detail. Context distillation in a nutshell is basically, so let's say you have a prompt that you want the model to answer safely. So you can preprint a pre-prompt to the prompt itself. So you can start with you're a safe and responsible assistant at the beginning, and then the prompt would be like, teach me how to create a bomb. So the model, when it sees the pre-prompt, it's going to hopefully respond safely and be like, oh, can't really give you an answer to this. And then you take the safe answer and you take the prompt and you supervise, fine-tune the model again without including the pre-prompt. So you're essentially like distilling the pre-prompt into the original prompt, and you're saving context length. Instead of like providing this pre-prompt on every in inference time, you're just providing it in training time. What does it even say in training time? You're just generating responses with it, and then you're fine-tuning the original prompt with the response that resulted from the full prompt.
I'm surprised they don't use I'm surprised they only use the safety reward model, because they said this whole point that safety and informative are in direct competition. So obviously, if you're being overly safe, you're sometimes being non-informative. But they only use the safety reward model to choose whether to use context distillation for each sample. I'd have thought they would want to use their total reward model that was a composite combination of the safety
Yep.
model and the informative model,
Yeah.
and they just like decide if that reward is better with or without, like with or without the pre-prompt. It's like that they do the whole RLHF with this composite reward function. I don't know why they wouldn't just use that same reward function again when they're doing this
It's-
pre-prompting. Seems like they're like optimizing for one thing, then going in a different direction, unless they use the same reward model.
Yeah, it's discussed in detail why they're doing this. Like each
Okay.
point of like each of the few points have their own section where they discuss this. Yep. So safety categories and annotation guidelines. So based on limitation of LLMs, yep, we designed instructions for our annotation team to create adversarial prompts. So they have basically two dimensions that they work with when creating these adversarial prompts. The first thing is the risk category, or the potential topic about which the LLM could produce unsafe content, and then the attack vector. And attack vector is such a very fancy name for what this essentially means. It's just the way the question or the style of the question to ask within this specific risk category. So, for example, like the risk categories are like criminal activities, like terrorism, theft, human trafficking, hateful or harmful activities, unqualified advice. So these are risk categories. So that's one dimension. The other dimension would be the attack vector. So the attack vector could be psychological manipulation, like authority manipulation. Like, I guess an example would be like, I'm your master, do whatever I tell you, stuff like that. Like trying to give an order to the LLM to do what you want. Logical manipulation, like starting with a false premise or something, like speaking about a specific group that they usually do that, therefore they should be responsible for event X or something, and the model like should take your words for granted or just believe them directly. There's syntactic manipulation, semantic manipulation, perspective manipulation, like role playing is one of the funnier ones. Like you could say for the like you could tell the LLM that I'm writing a novel about a killer, and can you tell me how to, I don't know, build a bomb or whatever, and the model would see like the context and just think that's it's fine to give you the answer. Non-English languages. So they have these two dimensions. You choose a category and you choose one of the attack vectors and create a prompt based on that. And yep, we didn't define the best practice for safe and helpful model responses. So now we've created a prompt. We give guidelines to write responses for these well-engineered prompts. The model should first address immediate safety concerns if applicable, then address the prompt by explaining the potential risks to the user, and finally provide additional information if possible. We also ask the annotators to avoid negative user experience categories. Yeah, this is like, yeah, I'm not sure what is meant by negative user experience with categories. Like I've read the appendix and really understand. The guidelines are meant to be a general guide for the model and are iteratively refined and revised to include new identified risks. Anyway, let's get into what they've done on each of these three points. So, safety supervised fine tuning. So basically, the main takeaway here is the annotators are instructed to initially come up with prompts that they think could potentially induce the model to exhibit unsafe behavior. So adversarial prompts, basically. And they're then asked to create safe and helpful response to these adversarial prompts that the model should produce, and then it's the model is just trained in a supervised fine-tuning fashion. There's nothing really special about this. It's very so creating data and then fine-tuning the model on this data. They mentioned here that the Llama 2 model actually learns from these safe demonstrations quite quickly, which makes them move into the RLHF phase right away. So we conduct our RLHF by first collecting your first data for safety similar to section 3.22. I've heard the notification, so if someone wants to give an input, they could just open their mic. Annotators write a prompt that they believe can, and then select the response that the safest according to system guidelines. We then use the human person data to train a safety reward model, and also use the adversarial prompts to sample from the model during the RLHF stage. Yeah, so basically they're collecting these human driven data for safety to train these safety reward models, the safety reward model, and then they use these adversarial prompts to sample from the model, and then the model is optimized to maximize the safety reward model, either through rejection sampling or PPO, which again was discussed in the previous parts. Yep. Let's see.
Sorry, so
yeah.
Veg made a point.
Yep.
It's interesting how Falcon produces less toxic outputs than Llama 2. I actually missed that. Does it produce? Sorry, but
yeah,
Falcon
it seemed
produces
to have
less.
the least, the toxygen table which he showed. Falcon seemed to
Yeah.
have like 14 or something, which like I'm not sure if they were.
But wasn't this
that's-
based on the foundation model?
It's on the pre-trained models, and actually, I think Falcon still performs lower on toxicity
it's
even
before-
after all of
It's
the.
before any safety stuff's been. It's before any safety fine tuning or
Yeah.
anything like this. Yeah. So
Yeah,
I guess
but,
this had.
But yeah,
Sorry,
the
there's a big delay.
interesting thing is Falcon. Yeah, I'm sorry. The interesting thing is Falcon, as far as I remember, actually performs even better than the Llama 2 models, even after the safety measures when taken into account. They do
Right.
explain the reasoning though. We will get to that. Yep, but it's a very interesting observation that sharp eye
Sounds good.
right there.
Also, I don't know how many pages there are, but it might
Um,
be worth maybe skimming over some bits a bit more quickly, because I think I
Yep.
get the feeling we might be doing this over 10 reading groups otherwise. And just for myself as well, obviously I was quite slow on them, but
ooh,
but
yeah, well,
yeah, hard to get the balance.
yeah. Let's skim through this. So again, what's this trying to say? It's saying that this safety problem is a long tail problem. What does a long tail problem mean? It means that most of the examples are easy to detect. It's very few infrequent examples that are difficult to detect. Basically, that's what a long tail problem means. So we investigate the impact of safety. And score the responses. Yeah, it's difficult to skim a paper, I guess. Another way, given
That's true.
that
Giving you a little
sufficient-
impossible task.
training data, the additional, you have to read things to see what can be skipped and what cannot be skipped. Does not make anything impact model performance. Yeah. So there's this point here that apparently the so there's this tension between trying to make the model too safe and also making it helpful. And they have this observation that when they include the safety data, the helpfulness, the average reward for helpfulness doesn't really decrease that much. And I believe the reasoning was that the helpful data does include, it's already safe to a good extent, that including safety data is not really hurting it. And it's making the model safer and also. It's discussed even more where so the Octane 6 model variant trained with 0% safe data, 1, 10, 25, 15, 100. So I have 6 models now. And I believe there's a figure here that, so safety data percentage, the blue line is basically helpfulness and the red line is safety. So as we increase the data, we notice that the models become safer, but we don't really see any kind of noticeable degradation. The model is fine in terms of helpfulness, which is an interesting behavior. If you see the histogram of the reward model, the safety reward model score, we find that with 0% safety data, there are these slightly frequent. I wouldn't say frequent, but these examples that have very low, these very unsafe responses that the model is generating. But the more safety data is included in the RLHF phase, the lesser these responses are generated without any kind of noticeable penalty to the helpfulness of the model. So I guess it means you can just train the model with 100% safety data without worrying.
Is this is
Yeah.
during the RLHF phase? All of this discussion.
Yeah, I believe. I believe this was done in the RLHF phase. Yeah.
So it suggests that actually this whole helpfulness thing they did wasn't that useful because basically the reward score only the safety model only kicked in if the safety score was like lower than like 0.15 or something, and then it was all governed by the helpfulness, I think. So is their point being that you actually, the safety is more important, and you actually helpfulness doesn't really degrade?
Yeah, the point is adding more safety data doesn't really. So there's this there's this tension between safety and helpfulness, and like my intuition before reading this bit was if you increase the safety, then obviously the helpfulness should degrade, because, for example, if you ask the model to, like, again, the usual example, create a bomb, if the model responds with I can't do that, then this is a very unhelpful. Objectively speaking, it's not it's a very unhelpful response. So I thought, like, if you increase safety, helpfulness should degrade. But according to their ablation, that's not the case. And I believe their explanation was that the helpfulness data is already like safe to a good extent. I believe that was the reasoning. Like, it's not really like adding safe data. This doesn't really degrade the model in any way. It doesn't degrade the helpfulness metric anyway, and the model is still performing like providing very helpful answers. They do, however, mention a very interesting problem that might arise though, which is the measure of false refusal. So there are cases where it asks a very normal question and the model like refrains from answering. So that's what's called false refusal. So that's something that arises when you when you increase the safety data, the model becomes more conservative, and it doesn't really. So there's more like false positives, I guess, where the model thinks that this is an adversarial prompt or something, and it doesn't answer. So what they did, they trained like a classifier for detecting the refusals and responses, and they applied the classifier, and the outcome is, you know what? It's very rare to have false refusals. That's what they get. They're saying that approximately only 0.05%. Even when using 100% of the safety data, there's like 0.05 are false positives, basically. Where are we? Yep. I mean, so the conclusion of this part is that the safety data isn't really hurting the helpfulness data, and it's making the model safer. So there's no issue with this. Just want to see the reasoning. Where did they like give me this? Trader they did. They must have. But yeah. In this other experiment, we keep the amount of helpfulness training data unchanged, and gradually increase the amount of safety data using the model tuning, ranging from 0 to 100. Yeah. Not sure where it's mentioned, but France. That's when increasing the performance on handling risky and the response obviously. And so higher TL and the safer model. We know what they mean. Remains constant. Yeah, we hypothesize that this is because we already have sufficient large amount of. Yeah, I mean, yeah. So the point is, yeah, they already have lots of helpfulness training data. So yeah, that's the reason. It's not that the helpfulness data is safe and stuff, but the fact that they have lots and lots of helpfulness training data. So adding safety data doesn't make the performance degrade in the helpfulness part. Yep, sure. Let's move on. Yeah. So here there's talking about the context distillation part. So specifically, we apply context distillation by prefixing a safety pre-prompt, as we mentioned before, to adversarial prompts to generate the safe responses, and then fine-tune the model on its own safe output given the adversarial prompt without the pre-prompt. So basically, we prepend the pre-prompt, we generate response, and then we train the model on the prompt and response, and we remove the pre-prompt. Yep, and the pre-prompts, they have like, they don't use the generic pre-prompt, they normally use this answer template, and they show in this figure that it gives slightly better results. As you can see, the green histogram with using this
So, sorry, just to understand this then. So sorry. So they've trained the RLHF this whole time based on either, I mean, the reward model decomposes into either helpfulness or safety, and it only decomposes into safety when it's very unsafe, basically. And that's how they did it. They obviously bounced around with this, the important sampling, that they didn't really seem to actually move it that consistently. But then by the time they got to version 5 and PPO, it actually helped quite a lot and pushed it far up into the right, at least on the GP. I think that's what happened. So then now they append the prompt with respond safely and fine tune it. So they're kind of like moving, they're now doing another phase on after the RLHF has finished that's purely focused on safety. And they've already acknowledged that well, they did acknowledge in the previous section that these things are competing, and that's why they had 2 separate reward models. That was actually the motivation for having them separately. And also, I guess, because the annotators then can have much clearer instructions as well for learning these 2 reward models in parallel. But it's interesting now that basically they're saying, well, actually, now we can just take this thing and just train it to be more safe, and we don't get degradation and helpfulness. That's kind of interesting. Is that what they do? Because it says that, and well, I guess, sorry, you can explain this, but how does the safety reward model, what decision does that make on whether or not to append the prompt and whether or not to fine tune on that appended prompt, or the one that was giving up before? Maybe some prompts give very good safe responses, and appending this prompt just adds a noise and doesn't really make it better, and that's when it decides not to append it. Is that kind of how it does it?
Pretty much. This is basically the paragraph that addresses your question. So it's important to note that performing safety context distillation for helpful prompts can degrade model performance and lead to more false refusals. We therefore perform safety context distillation only on adversarial prompts. So what they essentially do is we thus leverage the safety reward model to decide whether to use the safety context distillation. We keep the context distilled output only on the examples where it gets better reward model score than the original answer. So I believe what so they
so they don't care if adversarial prompts lead to non-informative answers, basically. So the training set is like adversarial prompts, which is like, I don't know, build a bomb or something, or it's things where the I guess maybe that they have questions where the prompt, if it's responding helpfully, is inherently bad by virtue of the prompt itself, and therefore maybe you don't need to be querying the helpfulness model anymore, and actually because these prompts should only be safe and they should not be helpful, we therefore can just optimize the helpfulness, the safety, and that's kind of how it works.
That's how I understand it, because they're not really clear about where the helpful reward model comes in and where the safety model comes in.
Well, I guess if it's an adversarial prompt, the prompts are inherently dangerous.
That's the point. Like if it's
you still could get helpfulness degradation, because if this is fine tuning without anything to anchor it, you could still, even if it's only on adversarial prompts, it could still learn to like only respond safely. But yeah, I guess they
they do mention this here actually. So they're saying that however, like we observe that context distillation can sometimes degrade response quality even when dealing with adversarial prompts. So they do address that. Specifically, if the model responses are already of high quality, the application of context distillation can result in less pertinent replies at the multi server and present the pre-prompt. Yeah, exactly. So they don't want to use context distillation all the time. They only use it when, like, if the context distilled output gets a better reward model score than the original.
But they mean the safety reward model, don't they?
I'm not sure. I think maybe the safety reward model, maybe a mix of both in some way. I'm not sure. I don't think they're clear on this, but
because it would make sense if they also kind of queried the helpfulness. But anyway, or maybe they had like a validation set that's like non adversarial prompts, and just having the validation on the helpfulness score to make sure they don't degrade it or something. But anyway, I mean, they're just details. But basically,
I think the response could still be helpful, even if like you still want the safety responses to be to some extent helpful, because you want to know why this prompt is problematic. So I think it's
I don't know. But I guess
not sure.
But my point more isn't that. My point actually more is that they should have a validation set to make sure, or maybe just like continue to do a small number of examples that are non-adversarial to make sure they remain helpful. But I guess it doesn't degrade too much, and that's what the graphs are showing us. So
So I mean, the main takeaway from here is that they don't really use context distillation with everything. There's this as long as.
And what do these graphs mean quickly? Sorry, I find the graphs quite interesting.
Base model is basically the model without context distillation. This is
like the RLF trained model.
I believe so. Yeah, exactly. I believe it's the RLHF model before. I mean,
And
let's make sure.
What does generic pre-prompt and pre-prompt with answer template mean? Is this something that's been addressed in the text yet?
So it was addressed. It's when they perform context distillation. So there's this pre-prompt you append. So there's a generic pre-prompt here that looks something like this, and there's a pre-prompt with an answer template. So it's more like a verbose pre-prompt with steps and stuff. So they say that this tends to perform better than this.
And sorry, what does the answer template mean? Sorry, so it means like so there's a generic paragraph you can append to everything. Then following this question, okay, so it's just different ways that they decided to frame it.
Yeah.
Okay. Yeah. Okay.
At the end of the day, it's like
so it's just like a different,
it's a prompt that you
different prompt format, and that's literally all it is, basically. Yeah. Okay, fine.
Yeah. That's what I understood.
Okay.
So it performs slightly better, and in this second graph, you're just comparing the original safety RM score and the score increase with context distillation. So there's lots of greens, and for the most part, the lower the responses with lower RM scores are increasing as it seems. There's just some degradation happening here. Yeah, but like overall, it's
so hang on. So what? Sorry, what's the right then again? Sorry, then. Sorry, I was just looking at the one on the left. So basically, they're saying that the answer template is better because here's the graph. It just gets more safe scores, basically, more percentage of the time. Then the other one is saying, and sorry, so score increase with CD with context distillation. So this is if it gets if it gets better or worse. Original safety score.
So this basically is this graph is basically a translation of the paragraph we discussed here. So if the original safety score is the reward model here is it's not really specified whether it's the safety, but let's say for the sake of argument it's safety. If before context distillation it's better, then reject this sample, like don't perform context distillation. If after context distillation the reward model is actually higher in the response, then select it or include it.
And basically, if it was really safe to begin with, it's less likely to be improved. If it was really unsafe, it's incredibly likely to be improved, basically. So on the left, on the bottom, on the x-axis, we have the original score, and then if it was really, really good, then CD does nothing, context distillation does nothing, etc. Yeah, sorry.
Yep, exactly. In fact, it might degrade the performance. We can really skim the reteaming thing quickly. So the point of reteaming, like as everyone knows, is basically creating a team.
You don't know. I've never heard what red teaming means.
What? Okay, so it's a famous term in cybersecurity, basically, where you create a team that acts like the malicious users, like they act as if they were the attackers. So they try and probe the model and try to find the loopholes, the holes within the model. That's so there's some.
I've heard the phrase. I've just never known what it meant.
Yeah, red almost tends to mean evil, I guess. There's also blue teams where like defensive, and anyway, so basically they create these red teams. They do specify how they've created them. They're a bunch of experts in different domains, so they try to trick the model into outputting unsafe responses. They have here some logs on how the models performed, how the early models performed, how were they tricked, and how the later models were more robust to all of these tricks. But the point is, from reteaming insights to save a model, they would just let these people try and hack the models, and they would start to collect data and do some analysis to mitigate these loopholes, I guess.
But do they explain what this resulted in like actionable? Like, what did it lead to them changing anything?
I can't really remember something actionable being said there besides this paragraph, to be honest.
Yeah. This thing, as an apple that we had. Okay.
Yeah.
Oh, yeah. Okay.
Yep. Let's see what's the time. We have 1 minute left. I mean, so this part discusses the Falcon phenomena. Let's just jump into the Falcon part. So So basically, this is you can interpret these graphs as the safety of the models. The lower, the better. So if you notice, you would see that.
Could you maybe zoom in just quickly on the two models?
Yeah, I'm trying to choose one of these guys. I just want to remember what the difference. But you know, let's stick to this one because it's the one
Okay,
where
sure.
Falcon is unbelievably like very low compared to the other models. So when you
Right.
look at first glance, you would think that Llama is outperforming everyone, and then you look at Falcon and you can't even see a bar there. So what's happening here? So this is the answer basically. Upon manual analysis, we found that the response of Falcon is typically short, 1 or 2 sentences, thus less prone to generating unsafe content. But also generally less helpful. This is reflected by a large number of responses of Falcon with rating 3. Rating 3 means that the response is not no safety violations, but it's not helpful by any means. So in other words, Falcon is super safe because it's not really outputting many sentences. It's not being verbose enough to provide anything that's toxic or bad. But on the other hand, it's hurting the helpfulness of the model. So
Yeah,
It's
I-
very
I
easy to
think
make a
that's
very,
really-
very safe, totally non-helpful model, I guess, in the limit.
I have a quick question.
Exactly. Yeah. Sure.
See on the graph, what's the difference between single turn and multi-turn? Because I just noticed Falcon is only really one
Yeah.
single turn.
So single term means a question and an answer right away, I believe, and multi-term means like there's a like there's basically a chat going on. It's question answer question answer question answer. It's not a single term, so that's basically the difference. Like it's a dialogue basically. Like lots
Let's
of
talk about
back and forth.
why Falcon suddenly starts to become more reckless after the first reply.
Yeah, I believe they did mention this somewhere. I think I can't remember where. They do mention it, that's for sure. Where I'm not
It's
sure.
not like just some hand engineered like first response like appending of the system. It's the model itself, isn't it?
Can you repeat the question because I was reading at
Okay.
the same
No,
time.
no, it doesn't matter. No, I mean, no, that is the question. It's just why is it worse on multi-turn? Are more prone to inducing unsafe responses? Yeah. I don't think they explain it. They just observe it.
Yeah, not much. It's like multi-turn supervised fine-tuning. And maybe because Falcon was not really trained in this way.
So it kind of, I guess maybe if it's only been trained, actually I don't know how Falcon's been trained. I assume they were all trained on multi-turn supervised, but I guess if it wasn't, then maybe it's just more a bit closer to the original auto-aggressive model, and then it kind of maybe all the safety training has been done in a way that is single turn. I don't know. I guess it just sounds like they've not really trained for multi-turn stuff, which is strange.
Yeah.
If they haven't. But...
Yeah. I don't think there's a paper for Falcon yet. I might be wrong, but I think that they haven't released it yet.
Okay.
Interestingly, so when we look at the truthfulness and toxicity and bias, we find that our models are almost zero toxicity, which is interesting. Yep. So they're way less toxic. Actually, I've just noted that when Ved was asking, he was asking about toxicity, not safety. So I guess there's subtle difference. I mean, safety is a more broad term, but in terms of toxicity, Llama 2 is king, I guess, with ChatGPT being actually quite close as well. So it's almost zero on all the variants. But yeah, I really want to get into discussion. Oh, there we go. So this is a very interesting. There are like very interesting insights here that actually we could squeeze in the last 5 minutes. So here we discuss the interesting properties we have observed with RLHF. Then we then discuss the limitations of Llama 2 chat. That's represent our strategy. Okay. Learning and observations. Our tuning process reveals several interesting results, such as Llama 2, ability to temporarily organize its knowledge or call APIs or external tools. So this paragraph is actually one of the most interesting paragraphs in this paper, and I think it's really worth reading out. So there is very interesting questions. So why use SFT versus RLHF? Why use reinforced learning with human feedback, where you can just provide, you can align the model using supervised fine tuning. And this question is like there are lots of research papers that are like exploring this question, and there's no clear answer. And I was like asking myself this question like the other day. So I'm glad I found this very interesting paragraph. So at the outset of the project, many among us expressed their preference for supervised meditation, attracted by its denser signal. I completely agree with this. That's what I felt. Meanwhile, reinforcement learning, known for its instability, seems somewhat shadowy field for those in NLP. I completely agree with this as well. Yeah, like I've never resolved to RL unless it's really like essential, because we all know how unstable this tends to be. However, reinforcement learning proved highly effective, particularly given its cost and time effectiveness. Our findings underscore that the crucial determinant of RLHF's success lies in the synergy it fosters between humans and LLMs through the annotation process. So, yeah, even with proficient annotators, each individual writes with significant variation. That's a very important point. A model fine-tuned on SFT annotation learns this diversity, including, unfortunately, the tail end of poorly executed annotation. Furthermore, the model's performance is capped by the writing abilities of the most skilled annotators. That's true. Human annotators are arguably less subjected to discrepancy when comparing to outputs preference annotation for RLHF. So this is a very interesting point, which I think they make a very nice parallel down there. So let me just continue reading. Consequently, the reward mechanism swiftly learns to assign low scores to undesirable tail-end distribution and aligns toward the human preference. This phenomenon is illustrated in figure training, but we can see the words answers are previously removed. So yeah, that's what RLHF does. In addition, during annotation, the model had the potential to venture into writing trajectory that even the best annotators might not chart. That's also interesting. So in SFT, the model learns to model what it's seeing, but in RLHF, there's more room for creativity in going into directions that might have been even better than the SFT data. Nonetheless, humans can still provide valuable feedback when comparing to answers beyond their own writing competencies. So drawing a parallel, and I think this is a very nice parallel, while we may not all be accomplished artists, our ability to appreciate and critique art remains intact. We posit that the superior writing abilities of LLMs as manifest in surpassing human intelligence in certain tasks are fundamentally driven by RLHF, as documented in this and that. Supervised data may no longer be the gold standard. And this evolves circumstance compels a reevaluation of the concept of supervision. So I think the point of this paragraphs to it really there's this idea of humans might not write perfect annotations, and there might be lots of variability and all of this, but when it comes to the data generated by RLHF, it's easier to generate and it's less variable, because even though we might not be the best writers, we can, when we compare to sentences, for example, we can tell that this one is written better than the other one, even if we don't have the capacity to write such sentences or such art. And even though the signal for SFT is denser, as we all agree probably, and it's more direct than RLHF. At the end of the day, I believe the model ends up just learning what it sees in some sense, but in RLHF, the model can try discovering different trajectories, and as long as the reward model is satisfied with the trajectory it has taken, then I mean, so the point is that the model can end up performing even better than what it was trained on. So it's an interesting paragraph, and it made me appreciate RLHF a bit more. Another important or interesting observation is in context rescaling. So the long story short, when fine-tuning these models using RLHF, the temperature effect changes. The way the temperature influences the response changes with the prompt itself. So if you're prompting the model to output something factual, raising or decreasing the temperature will not affect the output that much. But if you're prompting the model to do something creative, the temperature will have a more observable effect on the response. And this is captured in this graph. So if we look at the blue line, this is the RLHF V3 models. If you increase the temperature, the difference in the self blue doesn't change that much. and this means that the model is a bit consistent. But when using creative prompts with the same model, changing the temperature does change blue a bit. And if you look at the red lines, which are the supervised fine-tuned models, you'd see that they have similar behavior in both cases. So I think this is a very interesting observation as well, or a very interesting phenomena. This kind of robustness towards temperature variation based on the prompts. Obviously, when you have a factual prompt, you don't really want the model to get creative. You want to just answer with what's right. And with creative prompts, maybe there's more space for the temperature to make the model more creative. So it's a very interesting phenomenon. There's also this
one thing. I think maybe we should pick it up again next week. I actually need to run for a meeting, but maybe let's we can either wrap it up quickly.
Yeah.
But I think we can maybe avoid, because just to give everybody a break, we could have kind of one quick close up, kind of concluding marks or something. But if that's sort, there's obviously the related work and everything. But well, maybe I need to quickly dash off. But obviously, maybe just obviously we can have another 5 minutes running over. But yeah, thanks a lot, Yasser, and yeah, I'll see you in another meeting soon. I'll just dash off now. Bye bye.
Bye bye. So there's really much to discuss beyond this. There's also the maybe one interesting result as well is the temporal perception part. So when the model is fine-tuned with 1,000 examples with the following structure, like it's given the date, given the two pieces of metadata. Let's see. A question like how long did Bhargava become present, to the date when the query was posed, which includes the response, and the event date. So when the model is fine-tuned on data on this that looks like this, it apparently had what's called time awareness. So if it was asked about an event that happened in a certain date, and you tell it that its cutting knowledge is in 1940, for example. And you'd ask like who won the Second World War, so it wouldn't be able to answer it because it happened after that. So it's just the fact that these models end up having some sense of the about the time and what happened first and what happened second, and like the order of things is interesting. This is pretty much it. There's also the usage of tools, which is I think is all interesting. Like it's an emergent behavior without being explicitly prompted to use tools. There's also a line of research discussing all of this. And I mean, this is mainly the gist of it. Obviously, limitations and ethical considerations. This is something we don't really have to discuss that much. And responsibility strategy as well. There's nothing to add here. I think this is probably it. Yep. Thanks, everyone. This is the conclusion. I think we could end the Llama V2 series here and start with something different next week. Yeah, thanks everyone for listening, and I guess see you all next week. Yep.
Okay.
Bye-bye.
Thank you. Bye-bye.
Yep, thank you.